Okay, so the last thing we're going to look at this week is section 2.1, which is pretty short, and then part of section 2.2, but we won't finish it today. All right, so I just want to graph that. Okay, that's an example of a polynomial. We'll talk more about the definition of a polynomial, but that is one. Let's just graph it and see how many times it crosses the x-axis. So we've got 2x cubed minus 3x squared minus 3x plus 2. I'm going to do zoom 6, and I think you'll be able to see it. If you're doing it on a calculator or if you're just looking at the board, you can definitely see it. All right. Let me double check I typed everything right, because 2x cubed minus 3x squared. So put what I put on the board, not what I typed in. I accidentally put a plus as a minus. Minus is a plus. Okay, so how many times does it look like that graph crosses the x-axis? 3. It crosses 3 times. Okay, so I'll put this over here, just make it a little smaller. But it does cross 3 times. Now, so there's 3 different coordinates that you could tell me for locations of where it crosses the x-axis. If you gave me any one of those 3 coordinates, what would the y value be of each one of the coordinates where the line crosses the x-axis? All the y values would be the same. 0. They would all be 0. Yep. So the y values would all be 0. Because it's right on the x-axis. All right, so what I'm going to do is show you that what I've written right here, don't worry about how I got that, you don't need to know that yet. But what's in that box right there is exactly the same thing as what I have right there. I'm going to show you they're identical. Okay? And the way I'm going to show you is I'm just going to do it out. Okay? So I'll FOIL it out. I got to do the first 2. Get the answer, and then I'll FOIL it with the last one. So I'm going to forget about x minus 2 for now. Okay, I'm just going to FOIL the first 2. So x times 2x is 2x squared. X times negative 1 is negative x. 1 times 2x is 2x. So I get a negative x plus 2x. How much is that? Yep, x. And then 1 times negative 1 is negative 1. So that's the first 2. Now I'm going to do it one more time and see what I get. So x times 2x squared is 2x cubed. X times x. What's x times x? X squared. Very good. And then x times negative 1 is negative x. And now do the negative 2. Negative 2 times 2x squared is negative 4x squared. Negative 2 times x is negative 2x. And negative 2 times negative 1 is positive 2. Now if I combine my like terms and I did this correctly, that should be exactly what we started with. Let's see. So 2x cubed, got that. What's x squared minus 4x squared? That's a negative 3x squared. What's a negative x minus 2x? That's negative 3x. And then a plus 2. Okay, let's go back up and see. So we got 2x cubed minus 3x squared. Yep, 2x cubed minus 3x squared minus 3x plus 2. Minus 3x plus 2. So I just proved to you that what's in that red box with the parentheses, it's exactly the same thing as what's up above. Now, why I did that, I'm going to show you in 1 second. Let's use the calculator, and let's find one of the places that the graph crosses the x-axis. So we're going to do second calc 0. We're trying to find a 0. A 0 is where it crosses the x-axis. Okay, I'll do the one on the left. You could do any of them. Pick a point to the left, pick a point to the right, and hit enter. And then just put your guess kind of close to where you think it crosses. And I get an answer of -1. All right, let me do it again. Second calc 0. Okay, I'm going to do the middle one. If someone can do the one all the way on the right, that'll just save me having to do it again. Okay, but I'm going to do the middle one. Pick a point on the left, pick a point on the right, do a guess, and it says the middle one is 1/2, okay, or 0.5.
And the other one is 2.
And the other one, you said it's at 2?
Correct.
It's at 2. Okay, so those are all the x values that cause, that's where the graph crosses the x-axis. And if you wanted to write them as coordinates, it's -1, 0, 1/2, 0, 2, 0. Okay. We just mentioned that idea that the y values is 0 earlier. Now, look at what's in parentheses. X plus 1, 2x minus 1, and x minus 2. And we just figured out where that was equal to 0. That's what we just did on the calculator. We did second calc 0. Well, thinking about it without a calculator, if you multiply 3 things together and the answer is 0, what does that mean?
At least one of the numbers had to be 0.
At least one of these things, either this one, or this one, has to be 0. One of the 3 has to be 0. It's the only way you can multiply 3 things together and get 0. Well, let's look at the first one. If you subtract 1 from each side, -1 is what you plug into the first one to make that 0. Well, look at that answer right here. Let's look at the second one. Add 1 to each side. 2x equals 1. Divide by 2. If you plug in 1/2 for x, 2 times 1/2 is 1. And 1 take away 1 is 0. And look at the second answer the calculator gave us. So the reason why you would want to write something like this with parentheses versus like this without parentheses is because when it has the parentheses, it makes it very easy to find those 3 numbers. If you can't write it as parentheses, it makes it very hard. Okay? I can't look at the original problem and just guess that if I plug in 2 for x, it would work. But it does. If you take 2 and cube it times 2, and if you plug 2 in from all the x's there, you'll get 0. But that's a lot harder to figure out than writing it this way. So eventually we'll practice how to do that. Okay? So if you can find a number like we did in the last problem, we found 3 of them. What were they? 1/2, 2, and -1. I think that was the other one. If you can find a number like that, okay, and it's a solution to the equation f of x equals 0, that means when you plug it in for x, you get 0 for y. This is called an x-intercept. Okay, in the last problem, we had 3 of them. 2, 0, 1/2, 0, -1, 0. So a number that you plug into an equation that gives you 0 is the coordinate of an x-intercept. That number that you plug in right there is called a 0 or a root of the equation. Okay. On our calculators, when you go second calc, the second option is 0. On an older calculator, like this one, if I go second calc, I don't know if you can read it well, but the option it says there, I can't drag it, it says root. Okay, so the term root and 0 mean the same thing. So you could see a lot of different directions for a problem that mean the same thing. Find the roots of the equation. Find the zeros of the equation. Find the x-intercepts. Find where the graph crosses the x-axis. I just asked you to do the same thing 4 different ways. All the same thing. Okay, so let's look at this. This one's a little simpler. It's not as complicated as the last one because there's no exponents in it. Okay, last one had a big exponent, had an exponent of 3. You might have noticed the highest exponent was a 3, and it crossed the axis 3 times. There's kind of a connection there. Just because it's a 3, it doesn't guarantee it's going to cross 3 times, but it does guarantee it won't cross more than that. Okay? So whatever the highest exponent is, you can think of that as a limit on how many times it could cross, but it can't cross more. All right, so let's look at this one. This is basically an equation in y equals mx plus b. It's like a line. We're trying to find where the line crosses the x-axis. That's why it's equal to 0. How many times can a line cross the x-axis if it's not a horizontal line? Yeah, just once. And maybe a horizontal line wouldn't cross at all, but that's a different case. Okay, any other line, vertical, on an angle, will cross once. So how would I solve that to figure out the answer? That would be my first step. Rebecca?
I have no idea.
We're just trying to get x by itself.
Subtract by 3 on both
Yeah,
sides.
subtract by 3. And then
Divide by 2.
divide by 2. So if you wanted to know where that graph, y equals 2x plus 3, crosses the x-axis, it's at -1.5. And it won't cross at any other spot because lines don't curve. Okay. So anytime you want to figure out where something crosses the x-axis, set it equal to 0 and solve. For a line, you get one answer. How about for a quadratic? How many times can a quadratic cross the x-axis? At most, yeah?
At most 2.
At most, it could be 2. That would look like this. But it doesn't have to be 2. It could be 1. So, actually I'm going to write it like this. So you could have 2, 1, or 0 if it was up there. So how many zeros can the graph have? How many roots can the graph have? How many x-intercepts can the graph have? Same question, 3 different ways I asked it. The answer is 2, 1, or 0. Now, we came up, I don't remember if it was yesterday or I think it was the day before, this little calculation, b squared minus 4ac. If you do that calculation out, it gives you a quick way to figure out how many times it crosses the x-axis. It gives you a quick way to figure out how many zeros you have. It doesn't tell you what they are. All it would tell you is, do you have case A, case B, or case C? And the whole key is, I think we wrote it down, if it comes out less than 0, equal to 0, or more than 0. Okay, and again, I'm not going to write it all again because we already did. But does anybody remember how many roots there are if this comes out less than 0? 0, right? None. If this comes out less than 0, remember this is the part under the square root in the quadratic formula. If it comes out negative, you're not taking the square root of b squared minus 4ac. It would be imaginary. So if it comes out less than 0, there's no solutions. That's this case. If it comes out equal to 0, well, that's this case. If it comes out greater than 0, like say it comes out to 9, that's this case. Because if I were to take the square root of 9, I get 2 answers. So keep that in mind. Less than 0, equal to 0, more than 0. Tells you which case you have. Okay, so let's look at this one. That's not quite set up the way we would like it. Anytime we want to find roots, what do we always have to get the equation equal to? Yeah? 0. So I like to keep the squared term positive, so I'm just going to put everything on the left. So plus 2x minus 1 equals 0. Now, very quickly, without doing a lot of work, I can tell you if this is case A, B, or C. So A is 2, B is 2, C is negative 1. B squared minus 4AC. Negative times negative is a positive. 4 plus 8 is 12. 12 is a positive number. I can tell you that this is going to be case A. It's going to cross the x-axis twice. Where? I don't know. I have no idea. But it is going to cross twice. Now, let's solve it. Since they say I can do it approximately, that means I can use a graphing calculator. If they wanted it exact, what's the other way to solve a quadratic equation without a calculator? What do you have to use? Yeah?
Isn't it the quadratic formula?
You would have to use quadratic formula. Okay? Negative b plus or minus square root of b squared. If you want the exact answer, you've got to go through all of that. Yeah?
How did that one turn into a positive?
Because it was minus a minus. It was minus 4 times a times negative 1. So whenever you have minus minus, it becomes positive. Okay, but since this says approximate, I'm just going to graph it and see what I get. So I've got 2x squared. Let's type that in. 2x squared plus 2x minus 1. Plus 2x minus 1. Let's do zoom 6. And it's a U shape. It might go off the screen. No. But it's exactly the case I told you. Cross twice. Question?
What's the name of the symbol between the two fours behind the calculator?
The name of the symbol behind the 2 4s. Where are you looking again?
Behind the calculator. It's on.
Oh, behind the calculator.
Yeah.
Yep.
For
This symbol?
Yeah.
Oh, plus sign.
Oh, okay.
It's just that it was a minus and I crossed it out to make it a plus.
Okay.
Yep. So it turns into a plus and a plus. All right. So now second calc 0. Okay, I'll do the one on the left. Okay, if someone can get the one on the right, that'll help us out a little bit. So go left, go right, and do your guess. And one of the answers is negative 1.37. And there's one more, which looks like it's about 0.4. Looks like it's a little less than a half.
0.36.
0.36. Thank you. Okay. And those are the two answers you'd get if you did quadratic formula. One would be from the minus of the square root. One would be from the plus. Okay. So any questions on finding a root using the graphing calculator for a problem? Okay. Finding roots graphically, I've already gone through this with you. If you need to write it down again, you use the 0 feature of the calculator. The old method was when that feature didn't exist. There used to be some calculators don't have second calc 0, so the only way you can find it is you have to keep zooming in to try to see it closer and closer and closer, and that takes forever. So now we don't have to zoom in closer and closer and closer. We can just use second calc. Sometimes it's called 0, sometimes it's called root. Depends on the calculator, how new it is, what brand it is, things like that. Okay, so let's solve this one. Okay, anytime we solve an equation, what have we always been getting it equal to today? 0. So let's get it equal to 0 and solve it. How many times could this graph cross the x-axis? 3 times. It could cross 3 times. I guarantee it won't cross more than 3. But it might not cross 3. Let's check it and see. So x cubed, no trouble, plus 2x minus 1. Plus 2x minus 1. Okay, so if you graph it correctly, it should look like that. And that doesn't cross 3 times. It only crosses once. Second calc 0. Pick a point left. Pick a point right. Do a guess. And you get an answer of 0.45. That's the answer. Did anybody that tried it get an answer of 0.45?
Yeah.
Yep. Okay. And that would be one we don't even know how to do without a calculator. We have a formula when the highest exponent is a 2. It's the quadratic formula. We don't have a formula when the highest exponent is a 3 that we know. Is there one? Yep, there is. But it's usually not something that you learn in high school. So you'd have to use a calculator for that one. Okay, any questions on that? All right. So the kind of graphs we've been looking at a little bit are third degree polynomials. Remember, degree is just the highest exponent. Okay. So in general, you could have a third degree polynomial that has every single term in it. Cube, square, linear, constant. D is the constant. Some problems have every term, some don't. This one had cubed, 0x squared, didn't have the x squared, has a linear, has a constant. So that's missing the squared term, but that's okay. Page 80 shows you the different kinds of cubics you can have, but I'm pretty much showing you them right here. So the basic behavior is they go up forever, they go down forever. Sometimes as they're going up, they curve back on themselves a little bit. That's where you can get the case where it crosses 3 times. Sometimes they don't, like this one. This one just kept going up. So this one is kind of like this one. But it's even a little more stretched out. But I would put those two as the same type. Okay. So those are the 4 different kind of cubics you can have. Keep in mind, these turns can be more pronounced. You can have one that goes more like that. It depends. But basic idea is they either go up on the right, down on the left, or up on the left, down on the right. It's one or the other. Very different from a parabola, which parabola is up, up. Up on the left, up on the right, or if you flip it over, the parabola is down, down. Down on the left, down on the right. Okay, so cubics are different. Right, so let's graph that and see how many solutions it has. Now we're setting it equal to 0. So what does that mean we're finding? We're finding the what of the equation? The root. That's one way to say it. What's another way?
X-intercept.
We're finding x-intercepts. We're finding the zeros. That's what we're finding. Alright, so we've got x cubed. Okay, just from the first term, we already know how many times it could cross the axis. How many? Could cross 3 times. And for right now, that's all they want to know. How many times does it cross the x-axis? I see 1, 2, 3. So this one does cross 3 times. Any question on why it crosses 3 times? Okay. Now, the next part was to find the middle answer. This one. Is there any questions on how to do that? The second calc 0? If there's no questions, we'll just skip it. You second calc 0, pick a point left, pick a point right, do a guess. We did a bunch of them today. So don't worry about finding the middle root. And if you're wondering, well, why did they say the middle one? I don't know. They just picked one. Just practice finding a root. Okay, so that's it for 2.2. So last thing we're going to look at, part's pretty short. We're not going to finish all of 2.2 today, but it's just a little bit of practice again with zooming, okay, and finding complete graphs. Just keep in mind that, and again, you don't have to write this down if you already know it, but when we're solving a problem, there's generally 2 approaches you can take. You can try to set up an equation and use algebra, or you can draw a picture like a graph and use the calculator. Those are basically the 2 approaches we take to every problem in the class. Sometimes we use a combination of both. Sometimes we make an equation first, algebra equation, and then we solve it on the calculator. But that's all that is. That's what you've been doing all year so far, so don't really worry about that too much. Okay, so this is an important problem for the testing. Definitely a good one to know how to do or put on a reference sheet if you're going to make one. So it says that Bill is investing $20,000, and there's 2 different investments he's going to put his money in. One of the investments pays 6.75%. The other investment pays 8.6%. So you might say, well, why doesn't he just put all his money in the investment that pays more? Well, maybe there's a risk with that one. Maybe he could lose money or something like that. You know, so I don't know. But anyway, there's 2 investments, and both of the investments are what we call simple interest. So interest, you know, we know what interest is, right? Money that the bank gives you because you just let your money sit in the bank. You know, they have your money, so it's like a thank you for letting us keep your money. Well, we have to know the formula for simple interest. Okay? And that's a formula you need to know. It's I equals PRT. So the amount of interest that you make in this investment depends on 3 things. 1, how much money did you put in the investment? The more money you put in, the more money you can make. The rate. What is the interest rate that the investments pay? If something pays 8% versus 3%, 8% is higher. You make more money. And T is time. That's how long you leave your money in the investment. The longer you leave it, the more money you can make. Now, notice I wrote rate as a decimal. So what that means is if they give you something as a percent, you need to change it to a decimal. So 12% would turn into 0.12. You just move the decimal 2 places to the left. Change percent to decimal. So let's find an equation that shows us the amount of money that Bill would earn in 1 year. Now, to start you off, we don't know how much money he puts in the first investment, and we don't know how much money he puts in the second, but we've got to pick a letter. So let's just let X be how much money Bill puts in the 6.75%. We don't know how much, we just call it X. Now, we want to find a representation for the interest that he earns. How many investments is Bill doing in this problem? 2. Bill has 2 investments. He's going to earn interest from each of them. So, if you earn interest from 2 investments, what would you do to find the total interest you earn?
Average them.
So let's say you were getting paid money each day. Let's say you made like $100 on Monday, $200 on Wednesday, $300 Thursday, whatever. If you wanted to find the total amount of money you made for the week, would you average all that?
Yeah, together.
Add them together. Yeah, add them up. So what we have to do is find out how much interest does Bill make here, how much interest does he make here, and add them up. So let's start with 6.75. So the formula for his interest is I equals PRT. Okay. So the first thing is the principal. How much money is being invested? So for the 6.75%, how much money are we putting in that investment? X. Yep. That's the principal. Next thing in the formula, the rate as a decimal. What's 6.75%? 0.0675. Yep. And the last thing in the formula, time. How long does this problem say to do it for?
1 year.
1 year. So actually we don't even really need the 1. Okay. So the interest is 0.0675x. You can leave it as x 0.0675, but we usually put the number in front of the letters. That's the first one. Okay, let's look at the interest for 8.6%. Okay. Now, how much money did Bill have to invest originally? He had $20,000. He already put some of the money in the other investment. So, how much money does he have left to put in the 8.6%? Yep. I like the idea of subtracting. We're definitely going to do something with subtracting.
Is it 20,000 minus?
It's 20,000 minus how much money did he put in the other investment? Yep.
0.0675.
Well, that's how much interest he earns, but how much money did he put in that account?
Yes.
Just X. He put X dollars in the 6.75. So if X was 5,000, that means he has 20,000 minus 5,000 left. He has 15,000 for this account. So it's 20,000 minus X. What's my rate? 0.086. And again, the time is 1 year. Now, this one has a little bit more you can do because the 0.086 can be distributed. So let's distribute it out. 20,000 times 0.086 is 1,720 minus 0.086x. So the first one is how much interest he earns for the first investment. The second box is how much interest for the second investment. What are we going to do to get the total?
Add them together.
Do what?
Add them together.
Add them together. So take how much interest he earned at the first investment, how much for the second, and add them together. We still don't have a number because we don't know how much money he invested just, for x. They'll probably tell us that eventually. So the total interest is basically doing this. Take the money earned from the first investment plus the second. So let's look up what box 1 was. 0.0675x plus box 2, 1720 minus 0.086x. Do I have any like terms there? Yeah, the x's. So combine them. 0.0675 minus 0.086. So negative 0.0185x. Is that what it was? Negative 0.0185x. So now we have a formula. If you can tell me how much money he invested in the first investment, I can tell you how much interest you would make. But they don't give us anything else to do. They just said, find an equation that represents the interest in 1 year. There's an equation that represents the interest in 1 year. Any question on that? Okay, so now we'll finish up by using that equation to figure out something. We'll plug something into it. Now, remember, when you plug in, if x is the amount of money invested, are there any values that don't make sense? You could plug in 20,000 for x. That would be okay.
If it's over 20,000?
You can't plug in anything over 20,000 because he doesn't have more than 20,000. So you can't go over 20,000. What other numbers couldn't you use for x? Yeah, you wouldn't be investing negative money. That wouldn't make sense either.
You wouldn't be investing. I guess you could invest in all that.
So keep that in mind. That's what we just discussed. When you represent an equation from a word problem, sometimes you have to set limits on what makes sense. That's what I'm getting at right there. Okay. So it says, how much did Bill invest in each investment if he earned $1,509.10? Okay, so let me copy over my equation first. Can someone actually just tell me what was the formula we had for total interest?
Negative 0.0185x.
Thank you.
Plus 1,720.
1,720. Okay, so it said that Bill earned a total of $1,509.10. So where would that get plugged in? Well, X is how much money he's investing, but that's not how much money he invested. Yep.
Interest.
That's his interest. Earned interest. So plug that in, and that will tell us what's going on. So 1,509.10 plus 1720. Sometimes I solve it with a graphing calculator. Let's just use algebra. Okay. How would I get x by itself? What's my first step? Yeah.
Subtract 17.
Yep. Subtract 1720. And if we do $1,509.10 minus 1,720, can someone tell me what that comes out to?
Negative 210.9.
Negative 210.9. All right. And now what would be my last step? Yep. Divide by negative 0.0185. Divide by negative 0.0185. Negative divided by negative is a positive. And whatever that comes out to, that's my answer. Does anyone have what that? 11,400. So x is 11,400. Let's go back and look what x was again. X was the money at 6.75%. So that's 6.75%. How would I figure out how much money was, what was the other percent? 8.6. How would we figure out how much money he invested at 8.6? Yeah, if he had a total of 20,000 and he put 11,400 in the first investment, what does that leave me with for the second investment? 8,600? Is that right? So to solve it, it basically involves using that formula I equals PRT twice when you set up the equation. And then, again, you could use a calculator if you wanted for that, graphic calculator, or algebra is probably just as fast. Any questions on that? Okay, so that's definitely a good one to know for tomorrow. You know, somebody has two investments, two different percents, find the total interest. This one I think we already did. Does anyone remember what was the shape if you made a fence?
Square.
Yeah, and you wanted to cover the most area. In fact, I think that was the exact number we did. It was a homework problem. They just do it again. I don't know why. All right, so homework tonight. It's on page 82 and 88. I think 31 to 34, that's an interest problem. So 31 to 34 is really just one question. Set up an equation, find the total interest, and then solve it with algebra. So it's what we just did in the last example. 22 to 23 is also just one question. So unfortunately, if you get stuck on 21, it kind of makes it hard to do 22, because you need 21 to do 22. Okay, so we'll take a look at that tomorrow. Don't forget, I will be here for extra help if anybody has to stop by. And anything you need to make up after school, today is pretty much it. Okay, progress reports close next Friday, but you guys are in the shop.